To order the June 22nd meeting of the Oklahoma City Water Utilities Trust. The first item on the agenda is the approval of the minutes. Is there a motion? We have a motion. We have a second. Any questions or comments regarding the minutes? If not, please vote. Shall we? There it is. It passes 4-0. Next item on the agenda is the consent docket. There's a number of items on the consent docket. Is there a motion? Are there any items, and we do have a motion and a second, are there any items that the trustees would like to discuss individually? Hearing none, let's vote on the consent docket. And it passes. Item 4 is a concurrence docket. There are 2 items. Both of these are joint projects with the city. Neither of these involve any AQUIT funds. Do we have a motion? We have a motion and a second. Do we have any questions or comments regarding the concurrence docket? If not, please vote. And it passes 4-0. Item 5 is an emergency contract, which will require 4 votes. It's an emergency contract regarding an emergency sanitary sewer repair project on Northwest 22nd and 23rd Street. Any questions or comments regarding this item? If not, let's vote. And it passes 4-0. We have no items for individual consideration. Do we have any items from the trustees? Mr. General Manager.
Thank you, Mr. Chairman. I have a couple of items. First of all, I'll give you an update on the arrears. We're making some progress there. The number of customers has reduced from a few weeks ago, a little over 6,000 to 3,900. The amount of money in arrears has dropped from $5.9 million to $3.6 million, and the amount of water wastewater revenues in arrears dropped from $4.2 million to $2.6 million. I'd be happy to answer any questions you have in regard to that item.
Any questions regarding the monthly performance status report?
Yeah, that's a huge swing. Is there anything in particular you would attribute that to?
Yes, sir. We have started issuing shut-off notices.
That'll do it. Okay. Thank you.
Other questions or comments? Should we move on to the presentation on disinfection alternatives?
Yes, sir. Thank you. Will Huggins with our engineering group is here to present a comparison of chlorine gas versus on-site generated high-strength bleach or sodium hypochlorite for disinfecting purposes at our plant.
Good afternoon, Chairman and trustees. Appreciate the opportunity to present on the disinfection alternatives that Mr. Browning mentioned. Next slide. So safety is important to me, so I'd like to start with just a quick safety moment and thought it'd be timely to talk about chlorine gas. Some of you may or may not know the appearance. It's going to be green or yellow in the gaseous form. You can see from this picture here where it's coming out of this tank. If you see it actually within a liquid, it's going to be yellow, maybe slightly amber when it's under pressure. And if you look at the diamond there, the 4 and the blue diamond indicates the health hazard rating for chlorine gas, which is pretty much the highest it can be. It can result in death or substantial injury if you have even a small amount of exposure. And chlorine gas is much denser than air, so it's actually going to settle into a low-lying area, which compounds the health hazard. It's not going to escape above you. Next slide. So just wanted to talk about a couple things. So exposure signs, hopefully you'll be able to see it and know it, but if not, irritation to the nose and throat, irritation to the skin, And so if you are actually at a treatment facility that's using chlorine gas, it's important to check in with the head operator or the person who's going to be giving you a tour of the facility to know where, what the emergency response plan is, where the rally point is, and recommend staying close with them if you aren't familiar with the facility, and then having any proper PPE, personal protective equipment if you're going into the chlorine gas room. And then even at home, you could run into chlorine gas, mixing bleach with acids, which you may not think you normally do, but if you are using a glass or window cleaner, drain cleaner, those actually have acid in it, can actually react with your bleach to form chlorine gas, can be toxic to you. Same thing, bleach and ammonia produces chloramines. You typically see that used in our distribution system, but if you do it at home, can produce highly toxic fumes. And then same thing, even bleach and water, hydrochloric acid, or just splashing the bleach in your face. Next slide. So just wanted to go over a little background. What is disinfection and why do we do it? So disinfection is basically the removal of pathogenic microorganisms, either in potable water or wastewater effluent. So you're talking about your virus, your bacteria, and why is that important? Well, those can be obviously create illness in the public if they were to consume them. It's also environmental health risk. I'm from South Carolina originally, lived on the coast for a decade, so I love shellfish. And if your wastewater effluent has pathogens in them, it actually can end up contaminating the shellfish, which in turn would contaminate the public health or make the public ill. And the other is just permit requirements with having either potable water or the wastewater effluent. Next slide. So as Mr. Browning mentioned, we looked at some alternatives to our disinfection strategy for all the Oklahoma City water utilities facilities. And so right now, all facilities except for Chisholm Creek, so that'd be water and wastewater, except for the Chisholm Creek wastewater plant, use chlorine gas. You can see the 50-ton cylinders there at Hefner, and there's a schematic. I'm not going to go into in detail, but basically, gas pulled from the tank goes through a rotometer measuring device. It's then injected with high-pressure water into the treatment stream. And what's used at Chisholm Creek is bulk sodium hypochlorite. You can see the two large bulk storage tanks, and then there's small metering pumps that pull sodium hypochlorite, which is really just a fancy word for bleach, which is another fancy word for chlorine, and injects that into the treatment stream. Next slide. So we looked at, another option that was looked at was on-site sodium hypochlorite generation. So basically, it's a simple process done with the complex equipment. So you take salt, water, power, and it eventually shoots out a sodium hypochlorite or bleach, and at varying concentrations depending on the system that you use. You can see the schematic here, shows a water softener, which is just kind of to remove contaminants from the water that's used in the bulk system or the generation system. Next slide. So the big thing we kind of looked at non-financial versus financial, and we had narrowed down to look at chlorine gas, which is existing, and then also to look at the on-site sodium hypochlorite generation system. So when you look at the slide, there's a lot of colors. The blue basically indicates that the two items are very comparable. There's not really much of a difference between the two. Red would be a disadvantage of that particular system. Green would be that system has an advantage. And there's one black one up there that's just really, it's not really a disadvantage or advantage, but it's not similar either. So both produce a stable disinfection process, consistent quality. Both have a reliable chemical availability. Chlorine gas, though, has seen price instability, particularly in the last year, related to the paper industry. Why? Because chlorine gas is a waste of sodium hydroxide, and that's used in the paper industry. Paper industry is not as high production as it is now, which means chlorine gas is more expensive. But salt, which is the main chemical for on-site sodium hypochlorite generation, very stable, very known raw product. As far as utility-wide standardization, obviously chlorine gas is what our staff knows, but the on-site generation system, while it is complex in terms of the main components, it is easy to convert the system over to use. and train our staff on the use of that system. And then as far as continued disinfection during emergency, both systems would be powered by an emergency generator, and both would have bulk storage on site. So they're very similar there. One of the biggest discrepancies is safety. As I mentioned in the safety moment, chlorine gas is extremely hazardous, requires special training, and also risk management in terms of EPA's risk management plan. Requires the use of gas scrubbers, which provide protection to staff if there was a leak. There's transportation hazards inherent with it as far as bringing in large volumes of chlorine gas through the city on tanker trucks. Whereas on-site sodium hypochlorite generation, minimal risk. It's basically bleach. You have it in your house, just basically protecting your eyes in general. And then there's no EPA risk management plan rules that apply to this system. Next slide. So second component is looking at financial analysis, which comprised of two major items. Capital cost, which is going to be all the infrastructure that goes in to create the system, site work, buildings, chemical feed systems. And then your O&M costs, which would just be raw chemical, solid or chlorine gas, the power, maintenance as far as components, and then maintenance as far as labor costs, and then regulatory administrative costs, which primarily applies to the chlorine gas system. So we looked at those over a 10-year, 20-year, and 30-year lifespan or service periods. So for capital, we really took the capital costs and developed a debt service plan over 30 years. But we also included planned replacement costs. So for instance, on-site sodium hypochlorite generation system, you're going to have to replace that system after 20 years. So we have that cost included in the capital cost analysis. And then for O&M costs, we also included flow increases just based on population growth. And when you add those two together, you end up with the total cost. Next slide. So there's a lot of numbers on these next two slides. You hit really the biggest thing to focus on is your 10-year cost, 20-year cost, 30-year. You can see how chlorine gas performs next to on-site sodium hypochlorite generation, and it's, in terms of financial standpoint, on-site sodium hypochlorite generation outperforms chlorine gas at the 10-year, 20-year, and 30-year mark. This is for South Canadian Wastewater Treatment Plant. Next slide. And this is one for North Canadian. Similarly, it outperforms chlorine gas at the 10-year, 20-year, and 30-year marks. Next slide. So based on the detailed analysis, utilities engineering staff recommends the use of on-site sodium hypochlorite generation for future disinfection facilities improvements within our system. It's more cost-effective, safer to operate, eliminates the mortality risk and significant injury risk associated with chlorine gas, reduces the risk to community as far as transporting large volumes of chlorine gas, reduces regulatory and safety training requirements. Just for reference, it's about $60,000 a year at North Canadian Wastewater Treatment Plant. And then salt, the raw chemical for the system, is readily available. And next slide. And I just want to thank you. I'm the one up here presenting a lot of the results, but Sydney Quick, our financial services manager, was really helpful, pulled a lot of the financial data together and processed it. Crystal Koala, the engineering manager, Mr. Browning, provided great input as we worked through it. And then the Infomark staff, as far as our wastewater contract operator, provided a lot of good real-world O&M costs for us. So with that, if there's any questions or...
Any questions or comments regarding the report?
Can we back up a couple slides
Yes,
to
sir.
the cost study? I'll go forward a slide or two. One more. Perfect. Or not, I don't care. So it looks like the 30-year total costs aren't as robust as we thought they would be. Is that because of the 20-year life of the equipment?
Because I mean, the on-site is more expensive from a capital standpoint, so you will see it as you start to replace some of those items. Particularly, you'll see it at, like, if you looked at the year by year, usually at 15 and 20 was where we had a lot of the major components have to be swapped out. And so because chlorine gas is less expensive from a capital standpoint, it gains a little more ground back, but is never able to make it fully up due to O&M cost associated with it.
Great, thank you.
Yes, sir.
I was given a little bit of an early briefing on this. I was really impressed by Will's approach on this. It's very detailed. I've covered all the bases on it and really, I thought it was incredibly thorough. So I really liked the evaluation that you did. Thank you.
Yes, sir.
Thank you, Will.
Thank you. No other questions regarding the report? Should we have a motion to receive the report? Motion to second, please vote. And it passed 4-0. I'm not aware of any citizens to be heard. Therefore, we are adjourned. Thank you.